Okay. Recording now. All right, back to the diagram. Okay, so yeah. So we're now talking about whether or not we're okay with making this a separate service. I'm also okay with us starting to build it into AI Gateway and using WebSockets and seeing how far we get with that. Because as long as we're not really tightly coupling it to some fundamental aspects of the AI Gateway that won't make sense to the Duo workflow service, then it's easy to just strip that out, right? If we put a separate route in for this, it's a completely separate code path and maybe just uses some shared dependencies, and developer tooling for getting it started, then I think it's easy for us to disconnect that later if we run into problems. The other thing, okay, so are we on board with this regardless of whether or not this looks like that? Right?
Yeah,
Like,
I think so. I think that makes sense.
okay. So
But one thing is not clear to me, like the gRPC connection, is it with the executor or is it with GitLab? It's not with GitLab, is that correct?
correct. Yeah. So the executor is going to get a token somehow from GitLab and then perpetually, well, for the life of execution, it will be connected to the workflow service directly.
Got it. So the gRPC connection will be with the workflow service.
Right.
That okay, that makes sense.
All right. The other thing, Mikolai left a comment talking about potentially, like in this same conversation happened on Wednesday. Sometimes, we expect the AI gateway may not have access to GitLab, whether that's because of how the customers deployed their own AI gateway or because this theoretical, scenario where we could use the cloud AI gateway for everything and the customer doesn't even have to deploy an AI gateway. But it did occur to me, if this actually works reliably via a long-lived gRPC connection or WebSockets, then actually maybe it doesn't matter and we could actually do checkpointing back around this way. So
That's what I think. That's what Nikolai was alluding to last time, actually. That we could use the same reverse tunnel to checkpoint as well.
right.
But it's
And
it's funny because you're relying on the client to checkpoint. Like that's an odd pattern, isn't it? Like,
well, I don't know. I mean, it is it's a perfectly reasonable pattern if we want this to be entirely cloud hosted, right? And
yeah, exactly. I
it
mean, I agree with it. I'm just saying it's odd to have to rely on the client to store the
the
checkpoints,
th
but I agree. I mean, I agree with the fact that it's a it's a valid pattern.
and I think it's also valid in us considering this whole thing as sort of like best effort. So like anyway, I'll move this like sync workflow state down here.
Mhm.
In between that, and then GitLab can still call a duo. Oh, actually, start workflow. No, it doesn't. No, I actually was meant to remove this line anyway in both diagrams um, because the
I,
start workflow goes through
I
here.
think the way we should draw these diagrams, first of all, is self-managed um and cloud, right? .com.
Right.
I think that
So
makes
this
it
we
like
can
better
we
to
can
have.
call this the self-managed flow, and it's the one that doesn't use direct connections here because um,
And so then
because
GitLab is in user land then, right? So the GitLab
yeah, we
GitLab
can
instance
call
is
that
in user land.
userland. It's not quite userland because that user should not really have the same privilege to
Yeah, yeah,
GitLab
yeah.
there.
I mean, let's call it enterprise network or something if you want.
Yeah,
Intranet, whatever.
now I'm just gonna.
Oh, no, this is going to complicate things. You're going to go and draw two networks now. This is becoming a
No,
network
this was
diagram.
just this. This is just user land, and then this was
Okay.
a customer infra, or customer network. I suppose in this case it makes more sense because we're talking about networking concepts as firewalls is what's actually at play here. Um,
And then GitLab lives there as well, right? In the
Yeah, sorry. Yeah, that's got to go back over here. It's got to be bigger, or other things can get smaller, but okay. GitLab is there too now.
Yeah, so this is GitLab on-prem, and then we should also draw GitLab.com because that's how the tokens come into
That's
play,
what this
right?
that's what this is.
No, I
Oh,
no,
you're
sorry, I meant even in the self-managed case, we have .com because that's the token generation process is from .com because the AI gateway.com needs to understand the token.
right. I agree with you. Do you know what exactly that looks like? Is it calling GitLab.com, which then
Yeah,
calls some cloud thingy service, and there's actually proxying going on through some cloud connector, right?
yeah,
Or
exactly. So what happens? The thing calls GitLab, yeah, and that calls that through a service account, I believe, and then that fetches that generates a token. Yeah, so now this looks good.
right. So that's our JWT token, right?
Yeah.
Okay, get JWT. But only question then I have is, do we need to draw like Cloud Connector or the other things into this architecture? Because I actually don't know how they work, but maybe they're not
I
that
think we are
relevant.
fine. Like Cloud Connector is just the all layers from so Cloud Connector lies between your workflow executor and your
And
workflow
this,
service. We should draw it because I'm not sure whether Cloud Connector actually supports gRPC. So that's something we should check with the Cloud Connector team.
why do they need to be in between these two things actually? Because they're going to validate the token and Duo Workflow Service can't.
No, actually, even the token validation happens in your workflow service, but I think they do some like rights management, like checking. Jesse would be super useful to answer this question.
Right.
But they do like some they do that and this unit primitive checks. So that's what they're doing there. Actually, Mikla may know.
So what I know is that the unit primitives are the features, basically, the way how
Yeah.
we're gonna allow different icons to have different features. And I think that the cloud connector actually generates the tokens, but I may be wrong on that matter.
Okay, this thing shows GitLab.com calling something called a backend service, which generates JWKS, JSON Web Key Set. No, what?
Yeah, that's different. That's to validate the token. It's not the GWKS is just a set of keys and
I
stuff.
think the backend service is the any backend service that we can connect. So backend service in our case is AI gateway.
Okay. Um,
We need to check with the cloud connector team whether they support gRPC and whether because they look at like the authentication bearer token on top, etc. I'm not sure whether yeah, I
but
mean we'll have to figure out how.
do they need to proxy it, or can't we just do something like have this thing go and validate the token with somebody else afterwards? Like, or like, isn't the whole point of JWT that it'll be signed and we can validate it ourselves?
Yeah, so we can so do a workflow service can go validate it from .com. So that's not a problem. So the token itself, I don't think they validate the token, but I could be wrong. But we can
Oh,
go and validate a token from .com. That's not a problem. So we
right.
can just use the WKS from .com to validate the token.
Yeah. Well, yeah, I mean, I think we can probably just add that detail later because and maybe think some things shift around here, but I think this is probably enough now for Jesse to actually go and add all of those specific details into this diagram. Assuming like
Yeah,
it seems like
I
we have
think
options.
let's
With
leave
the
an
cloud
open question for
connector,
cloud
one thing I may be wrong is that it serves as the load balancer or like the reverse proxy for the self-manage. So we may like make the first call to the cloud connector to really be connected to the one of the AI gateways. Um, so
Right.
I think we don't directly we do not make direct connection between the AI gateway, so to say, based on the IP or the domain address, but we rather go through the cloud connector and then go to the AA gateway. But I may be wrong.
And if that's the case, and like we can't figure out how to make direct connections, then we'll need to make sure the cloud connector can support
Yeah.
gRPC to get this to work.
Yeah, we need to figure out whether Cloud Connector, because they use Cloudflare workers, I believe, right,
Yeah.
on the edge. And so we need to check whether that supports this.
Looks like it.
It probably
Cloudflare
does. I don't know.
gRPC connections. Cloudflare offers support for gRPC to protect your APIs, proxy gRPC endpoints. Yeah.
I know. I don't know whether they support, like, the ports to be open and whatever else. So we should
Right.
just check.
Yeah. We'll add that to the.
Because
I
I
will
think,
actually.
although it does support it, I think it's like inefficient perhaps in the sense that, you're opening up these workers are charged per like call or something. And so if you've opened up this long running connection, then you're being charged constantly. So it's like running a function constantly on the edge, right? And so I think we should check with them.
Right.
But either way, we could probably implement some kind of way of like asking the cloud connector for like what is the actual physical address that I'm gonna make a call and then make this call or something like that. So
Yeah.
I would say let's not worry about it for now. Let's make our diagram, and then let's pull the cloud connector team saying, hey, this is what we're thinking about.
Yeah. Okay, and yes, we have lots of options there, and yeah, there's no reason that we need to keep a persistent Cloudflare worker running for this to make conceptual sense. So yes, we can ask them how they would suggest we implement it. Part of the reason I said gRPC rather than WebSockets, and I'm not even sure about either of these are true. This system kind of relies on this being a fairly reliable connection because, and I put it in the architecture blueprint, every time this connection drops, this entirely in-memory state needs to be checkpointed and shut down. So whatever's going on in LangGraph needs to be paused, checkpointed with, well, up here in this diagram, checkpointed into GitLab and shut down. And it needs to be restarted the next time they make a new connection. So, in the case of self-managed, if we don't persist it directly for them and they persist via the executor, they will lose progress unless they checkpoint it after this connection is dropped. So,
I was thinking how we would implement Duo workflow, and this is probably overcomplicating. But I was thinking that we'll implement it as the gRPC service being in Go, and it then spinning up these LangGraph containers. You know what I mean? So it spins up it like spawns the process. Like forget containers, like that's just complicating things. But it spins up a LangGraph process, and as soon as that gRPC connection is killed, we can then kill that process.
Yeah, which I mean, process or thread in or whatever non-blocking IO equivalent is, it's sort of all the same. That's kind of how I was imagining it as well. This over here exists as this ephemeral in-memory thing. In the same way that a normal request flow would work, you instantiate a request object that exists for the life of that request and then gets torn down. In this case, it's just a longer running request.
Correct.
Yeah, and yes, that could potentially be based on containers in Kubernetes or something else, or like.
No, I didn't want to complicate it with containers. Like I that's why I just said process. Because then now we're expecting more, right? We're saying, oh, now this needs to be Kubernetes. Like I would like to keep that service as simple as possible.
Yeah. Okay, so any other decisions we have to make here before we're confident that this is a good direction to go? We will ask, and I'm gonna put that now on the thing because, well, I remember. We will ask the cloud connector team, but well, actually, yeah. Anyway, I'm gonna start a note there. What else do we need to do?
Let's go back and let's look at diagram. So it works for self-managed, it works for cloud as well. That's what he's saying, right?
Yeah, in self-managed case, they won't be using our runners.
Yeah. So runners will also run in their own cluster
Yeah.
or whatever.
Yeah. Yeah. So runners there, and they may want to run runners and do a workflow service as well. I kind of didn't want to have to replicate this diagram and try to keep both of them up to date, but they are quite different now, so this makes sense.
Like what I've noticed in all these diagrams is like self-managed is the worst case scenario, and then the .com scenario just kind of falls into place
Yeah.
after.
But interestingly, this may be even simpler now for self-managed because they don't even have to run the Duo workflow service and whatnot if we can get this to work sensibly.
Yeah.
And yes, it is weird to go back via the executor to persist things. And in fact, I'm missing
Yeah,
those.
we should draw that diagram, the checkpoint state one, which is from no, do workflow. Yeah, no, checkpointer is going from,
Oh, sorry.
yeah, exactly.
Okay, so that is what we're missing. Okay, I'm gonna make those blue because that is new and important to highlight.
Now I'm just thinking, so for the reasons you mentioned about upgrades and stuff, we prefer this approach to just running it locally, right? I mean, there's a lot of architectural complexity that we bear because of this approach.
Yeah, I know, and I'm trying to think about the same thing. I think the only, I was sort of more sold on the idea of local running if we start saying we're building this open source tool, and that's like a big part of why people are running it locally. But the second was not making it open source. It just sort of doesn't make sense to say we're building a complex, long-running Python application that clients download and install and run themselves. It seems like it doesn't really match with how we would normally do SaaS product development. It's like if we can run it for the customers, then we would. And the only reason we couldn't, the only thing we can't run for them is the executor, which is why we give them that. And we can write that in Go, which means it's a single binary that can easily be downloaded into their existing Docker images that have their development environment set up, assuming they have such a thing.
Yeah, I mean, I just thought when we originally thought of local development, I was like, oh, this conforms with like the GitLab DNA of this is how we started, right? We had an installable that people could install in community edition and whatever. They could literally run it themselves. And then when they loved it, they bought the licenses for support, and enterprises bought the licenses for support. So it's like open core.
It's not really the same thing though, because even with original GitLab, it wasn't like you were expected to run it locally, right? Like the architecture was still like it's a web service that you deploy on a server somewhere, and
Yeah.
it's multi-tenanted. You've got user accounts and all of these things. The local running execution things just simplified it a lot because it was like, well, we're just sort of it's just people figure out how to run it and install the dependencies, and we don't have to worry about auth or all sorts of things. But like, yeah, that's kind of why I'm less thinking we would invest in that now. And like we would eventually want to get to something like this, run as much as we can cloud hosted if this is ultimately what we need the architecture to look like.
Yeah,
Yeah, I
that
mean, there's still that
makes
local. We can't avoid the local. That's the point. I mean, this is like a double-edged sword, in the sense that you still can't avoid the local Docker executor, right? You still need to run that, right? And
Yeah,
my
but
point is,
there's a go on.
if you're running the Docker container anyway, like that could be Duo workflows.
It could be, and I mean the difference I see is that a Go executable that keeps open a TCP connection and just shells out commands that it's told to is way simpler and needs way less upgrades. So like, we have to worry about customers, what versions they're running of all these tools. If the executor is on a very slow release cycle once it's stabilized, that really does change the rate of development we can do in the Duo workflow service, and providing more and more customer features without them having to be upgrading that thing. If indeed, that's the popular way to use this, but then there's the CI runner use case as well. So yeah, the idea of managing all these many versions, I mean, it is a little bit already tricky with like, we have self-managed running different versions, and then we have like all these editor extensions that are released in different version cycles, and we're building all these APIs between all these different things. The more we give the customers to run, the more backwards compatibility problems we have to solve, because the interface between the Duo workflow service and GitLab could be quite rich, right? This could be rich and evolving very quickly. And if they're running an old version of it locally, immediately, we have no way of kind of upgrading people really quickly on that.
Yeah, I see like two cases where we still might have to consider running things locally or within the customer network. The first is if you have a sensitive customer who runs an air-gapped instance, and they just say, hey, you just cannot connect outside. For example, I don't know, the federal government customers or the Department of Defense or the likes. That's one. The second would be that, let's say I'm a large customer that I have fine-tuned a model and I want to use everything against that model. Then I still have to run things in the customer network.
Yeah. I think I'm now trying to decide whether I copy the GitLab.com one and down this, but I think what you're describing is like longer term, we already want to get people running AI gateway locally, and we have custom models. We also have the security concerns you're raising. So overall, it will eventually look like that for the customers anyway, in which case the self-managed with local AI gateway can just look just like GitLab.com, which is customers.
So you just remove,
GitLab.
I'll tell you what, remove the boxes and stretch user land, and remove the box and just stretch user land all the way to the end of LLMs. So you go all the way to the end. Yeah. And so that's now customer network.
Okay, so this now aligns with what Sri was talking about, right? Sri, anything else we should capture in this to?
There's one more caveat. I think
Mhm.
that it just occurs to me when you were discussing the different versions, that when we're gonna especially go with this executor running all the commands, especially triggering the tools for us to integrate with GitLab, because the user GitLab may be on different version than it.com, we really need to factor it into account when you're gonna build these tools, and use the correct version and documentation and whatnot to make sure that the executor actually can execute the tool that the Duo workflows request from it.
Yeah, so I think what you're describing is that this middle architecture, while maybe sort of seems good that the customer doesn't need to run this, it may be painful for us longer term, and we would actually rather see customers running an in-sync version of Duo Workflow Service that matches their GitLab version, so that whatever tools the Duo Workflow Service thinks it can use are actually available in their GitLab instance. And otherwise, we've got to perpetually make this backwards compatible with whatever GitLab clients versions are using that. Or we've got to just have a really strict kind of like validation of versions, like the version kind of comes through with the token and we just reject and say, you actually can't run with Cloud Duo Workflow Service more than 2 versions ago. So if you need this, then you've got to switch to this
Also,
architecture.
I think it kind of depends how we're gonna build the tools. Like if we were very mindful about how we build the tools, like this experiment we have, that we build the tools basically off the Open API documentation, and we can pull this Open API documentation from the user instance. So like basically we only rely on to interact with GitLab on this documentation based tool and the API based tool. then we may build the workflow in kind of automatically backward compatible way. But you should be really, really careful when you're gonna build this dedicated tools. Like, oh, we know that, I don't know, the artifacts API, we want to call it very reliable way, and we're gonna build a dedicated tool, and we're gonna hard code this API shape as it is for now, and it then starts to be problematic to be backward compatible.
Yeah, I mean, my main thinking is that, if you like you said, if we build the tools using the API, they're always backwards compatible and they're not changing that much. But where I see will be like the rapid development of us like building new APIs specifically for new workflows, and then also almost in that same vein, like the actual checkpointing API and how rapidly it will need to be iterated on as we want to make checkpointing more have more functionality. But
yeah,
I think the fact that I sort of think this may be stopgap kind of thing, but it also might just help us with the conversations we're having about the AI gateway not being very easy for people to deploy right now. It kind of buys us some, benefits there. And we maybe don't even need to necessarily stress about implementing this straight away, so long as we say we can. And, prefer customers to actually deploy the AI gateway if people are getting to that in the meantime, which it seems like they are. But we have all three architectures as possibilities. And this one just requires considerations for backwards compatibility. And, maybe we limit tool releases to based on the version that the client is using. You don't have access to newer tools, and we design the tools that we want to be backwards compatible such that they will likely be backwards compatible. All right, what else?
So let's go back to let's talk about tool use. I think it's useful just to talk about tool use. So go to, self-managed is the right, no, self-managed is the right place. Let's start there because it's the easiest. So let's say we have to call an API to fetch an issue. So Duo workflow always goes to the executor to say, go fetch a.
So I was thinking it would look like this when it was a safe operation. So I was imagining we'd have petition tools in terms of safe and unsafe, or maybe not even safe. It's like things that need the file system. If you actually need the file system, you go via the executor. But if you just want to make HTTP requests that we've programmed ourselves, and you don't actually have the opportunity for arbitrary execution, we may as well just go to the API from the tool.
But you can't do that because, again, firewall issues, right? You can't go across our infrastructure to self-managed. Where
Right.
firewall issues will always be from the executor to Duo
Right.
workflow executor to GitLab.
Right, yeah. So if we're talking about the middle case, then yes, that it'll be similar to checkpointing in that we'll go, okay, I don't have a connection, so we're routing back via the executor. This is what you need to do, and it'll be described as an HTTP request or whatever. And we want you to just return us the raw response. So in that case, anyway, I realize now that this needs to say checkpoint as well.
I just want to say, don't draw that arrow. You don't need that arrow. You already have the arrow saying call tools, right? What is it?
Well, I never had a blue line for checkpointing to begin with.
But you don't need to checkpoint to the CI runner.
No, you need to, the Duo workflow service is keeping its state in memory. It needs to send checkpoints back through the executor to the GitLab instance.
Oh, yeah. Okay, I see what you mean. Okay,
because I drew these two blue lines, but I never had explained that the checkpoints actually comes from the workflow service.
Yeah. Okay. I got that. Yeah, now let's talk about tools, right? So for tools also, we have to go through the same route every time. Like every time you run a tool, it goes from Duo workflow service to the Duo workflow Docker executor, right? To then GitLab, right? So for every tool, because we have to call issues, on the self-managed API. So it's coming quite a messy diagram. But yeah, it calls it like that, or it calls same thing for the workflow executor, right?
Yeah, you mean over here?
Yeah.
Yeah. I do you want me to draw all those extra lines? Should I just use this example and not point?
I was just saying,
No.
Yeah, that's my exact point. I think don't draw the lines.
Yeah, well, I'm trying to
But
think
yeah,
which one's clearer, but yeah, we don't need all of them. I mean, we could maybe even remove CI runner from this diagram just actually to simplify things, because kind of it's assumed like CI runner will just work the same as a user would in
yeah,
this simple self-managed one. In which case, I'm going to delete that and I'm going to repoint all
yeah,
these. I don't need double blue lines though, luckily.
yeah.
Uh,
I mean, this is checkpointing in my mind. Again, I'm not going back to things. I'm just saying in my mind, the checkpointing is a bit wasteful in the sense that you're going to the internet. Let's take the .com case. So you're going from the internet to on-prem to checkpoint and back to the internet to actually checkpoint, right? Like it's like
you're talking about this case. The
yeah,
checkpointing's
yeah.
going
Because
directly to GitLab. It's
but
staying
why
in.
should we? I mean, we want to keep it constant, right? Like we want to build one thing, right? We want the
Okay,
architecture of all
well
cases,
that
so we don't.
I I was kind of under the assumption this is a fallback architecture, and um and it will be since the Duo workflow executor is implemented in a fairly kind of naive, just tell me exactly what to do kind of way, we don't really have to build it twice. Like the Duo workflow executor doesn't necessarily need to know what checkpointing is. It just needs to know it has a GitLab token and it knows how to construct an HTTP request to its GitLab instance. And we just give it a JSON payload and a path, right?
Yeah, so we'll have like the gRPC endpoint, for example. So the method would be proxy request or something, right? So then, let's write down the at least the methods for the gRPC bit. That I think that will also make it clear. So the gRPC endpoints that we have are so gRPC is written like an RPC, right? So the methods that we have are read file, write file, um, run command, right? Run command, and then the last one is proxy. Yeah, or HTTP GitLab, whatever you want to call it. So write file, run command, and yeah, proxy to GitLab, and that's it, right? Those are the commands possible. Now, one of the things that this obviously doesn't enable us to do is use the wealth of tools that LangGraph provides or LangChain provides. Like LangChain's got these tons of tools, like oh, send a Slack message or send any of these things. Like my original thought was that hey, we could just use those tools out of the box, right? Um, but now, like because we are fully customizing these tools, that it goes to this Duo workflow executor, and like customers can't use those,
I don't
that
know. I
huge tool.
mean, what send to Slack, it's going to be an example where that's internet connected and we don't need to proxy that via the executor, so we can use that. And we but I have a feeling that there might be, like in some of the Ruby HTTP clients, you just kind of stick middleware in there that look at the request that you're sending and do something with it. And maybe we've got some similar hackery we can do here with things that we didn't implement, but use a known pattern for HTTP requests. We just put a middleware in there that routes them through the proxy if needed. But it's unlikely that that's going to be relevant, right? Because if it's something that is sort of like an internet tool, then it should be possible to execute from over here.
An example of it is, let's say, search. Let's say we allow them to search,
Google,
like
yeah, web
it needs to do
search,
an arbitrary search,
yeah.
right? An internet search, or it needs to navigate browser or something like that. I don't know, right? Those kind of tools.
Do you want me to
Um,
draw these? But I
no, no,
think
I'm not asking. No,
because
let's
I
just
think it's
discuss.
fine for these things to just go out here, and in both cases, right? Like, and this one as well, it'll be.
Well, because the problem with internet search and all these things are that we need to do customer managed keys, right? Those are not keys that are
Well,
ours.
I
Like,
wouldn't. It depends. For an internet search, if they're paying to use our AI gateway and we have
Mhm.
credentials for an internet search API, they get to use it for included in their subscription. If they want a custom tool that uses a custom internal in their network thing, then yeah, it definitely has to go back via the executor anyway.
Yeah. I mean, I'm just thinking, I'm just thinking that we can't just directly include the line graph tools. Like we'll have to build a proxy for each of those tools, right? Like, we'll have to
But
build
an
an ERP.
example, we can include directly the internet search example you gave. What's an example we can't?
I'll have to think of some, but basically, let's say there's some. Again, we'll have to pull out. Let's say line graph tools and pull out some. I'm sure there's some of them which are like on-prem things.
Where do I find all the tools?
Uh, just search for Landgraph tool sets. Actually, if you search for tool sets, oh yeah, I can tell you. If you go back, go to
Tools.
tools, open up tools, toolkits, and then they have visit integrations. Yeah, that's the list of these are the tool sets, and you can click on each of them, and they will give you like, for example, the JSON tool or CSV tool or any of these which can read stuff. Like these tons of tools, they obviously presume that Landgraph is running locally.
Right. So we'll have CSV will work, JSON will work.
No, but
Like
CSV has to go back, right? Because it's reading a CSV.
No, it will never go to the executor in the first place. The executor just uses the tools that it can locally. It has each tool is annotated in such a way that it knows it's allowed to just use it, or it needs to send it somewhere. Oh, except for this one needs to read the file system. Okay.
Yeah, that's what I mean.
Okay, CSV needs to read that. It's not CSV of read. Okay. Yeah, in which case that one we need to figure out how to route that back through the thing. But that's unavoidable. If that's unavoidable based on the fact even with Google all the way back to the architecture we talked about the other day, where LangGraph is running locally and it sends commands to the Docker executor, you have exactly the same problem. Because LangGraph runs differently from where the commands run.
Yeah, but yeah, exactly. I mean, I agree with that. That's what I'm saying. So it is a problem, irrespective, right? When we're talking about
File system based tools.
yeah, but there's also like tools, for example, Office 365. Usually, any customer would have like IP allow list for Office, right? So they would say, oh, we can only access our Office instance from our our reverse proxies, sorry, our proxies. And so we probably won't be able to
They need
Office.
this architecture for that. That's the only I think
exactly.
I would say that's the only sensible way for them to run that kind of a scenario.
Yeah. Yeah. I mean, we should just call it out as a con, but then I think it's fine.
Right.
You know.
So yeah, as a downside, because we've separated LangGraph from the execution environment, that means that we don't have the file system in wherever LangGraph runs, and therefore anything that depends on the file system or the tools that are pre-implemented that depend on the file system or tools that are pre-implemented that are expected to send requests within your local network won't be possible for people to use with this proxied approach. Well, no, there's two different kind of situations though, because yeah, the Office 365 is very different to the CSV example. The CSV example, we just can't use this. We would just implement our own CSV one, or figure out if we can monkey patch it to send the request somewhere else and then like keep the majority of the Python code. But what it thinks is the file system is actually getting read directly using a read file command somewhere else.
Yeah, I mean, exactly. I mean, I think the CSV is probably a bad example. Like a read file is pretty generic that can just do the CSV bit. But I'm sure there's some of them, like there's a Cassandra database one, right? Which can go hit a Cassandra database. And that would obviously run on-prem. You need to then directly hit that somehow. So I don't know, like could be a problem, may not be a problem. Like Jira is another example, right? Jira may be running on-prem, right? And then you need to.
I wonder if because right now we said we would like to build this workflow executor as the Go binary because it's easy to distribute once compiled. But in the essence, like all these tools are the RPC. The LLM makes the RPC call to the service implemented in Python. And if we can just tunnel this RPC call back to the executor, so the executor is written in Python, then we can tunnel these tools and they will be executed and returned.
Yeah, I mean that's I think that's what also Dylan was alluding to. If you can find some way to just tunnel the tools, that could work.
Because in
Yeah,
the end, what the LM is.
what do you think is on the other side of those RPC calls? Do you have an example that you can explain it? Because I'm wondering if it's that much, like, if we kind of go against the way this architecture works anyway, we still need to rip out the middle of some of these tools. Maybe it's just as easy for us to rip out the middle and route it through Go, which is like reading from the file system or routing all HTTP requests via Go.
I think
if we
I
look
think
at
what Nikolai is trying to say
the
is that if we implement this in Python, right? If we implement the execute in Python, we can just say, we can make a simple proxy that says run tool with these args, let's say. So a single gRPC single gRPC method called run tool with these args, and we then give it access to all the LangGraph tools, etc. So it'll be then able to run the tool and pass the args in. That's what I mean. Like,
yeah,
because the LLM is constructing so LLM how the function tooling works is that the LLM gets the schema for the function, like the RPC schema, and it generates the call kind of like through the WS star or something like these old school system protocols. So it basically has this library of these RPC functions, schema functions, and the LLM generates like, hey, get me this call. And it sends it back to the other node, actually. So when we are discussing in the terms of the graph, in the LangGraph, the one node constructs the call in plain text, basically, and sends it off to the other node that executes and then return it back. So if we can just take this node that executes this call out and run it in the executor, then we basically can run any tool in the user network.
Yeah, exactly. So what he's alluding to, I think the implication.
I understand. I understand the difference. You write it if we write it in Python and we have all the dependencies available to it on the other end, then it will be able to just take the same RPC interface that was already happening internally in LangGraph and execute it over there. Yeah, I'm processing that. I mean, my biggest concern is I really did want to avoid the idea that we'd be bundling like a complex ecosystem of code to the client as opposed to a very small executable that is fairly stable that the client that doesn't, we don't have to worry about upgrading so much. Like, I don't know, GitLab runners, for example, are very compatible with like forward compatible with many GitLab versions because the API between GitLab and the runner is very simple. So people install GitLab CI runners and they tend to just keep working.
That's a really good point.
And
that's
so,
a really good point that if we're gonna rip it out, then like if we add more tools on the service and then there's somebody running the older version of the executor, the service gonna try to make a call to the tools that are not present on the executor, and that could be quite messy.
No, I'm just saying the executor, if you write the executor in Python, then I'm saying that we'll include the LangGraph tools in that executor, right? So it can run any of the LangGraph tools. And then when the YAML specified has a LangGraph tool, for example, so we just have the gRPC service is very simple, just one method in the gRPC service, which is run tool. And all it takes is an arg, which is map of string, right? And so so all it does is it invokes the tool and passes in the args, which are generically formed in terms of map string.
Yeah, that makes sense, but it's not the interface between the two components that I'm worried about. It's what you bundle into the executor, what code the executor needs to have in it in order to be able to execute exactly the same tools that the other end thinks it can execute.
So I'm saying that the tools will be pretty simple in the sense we'll have a read file, write file, and run command, which are the tools we've written, and the rest are just the LangGraph set of tools.
Yeah, but
Yeah, but the
consider
line
scenario
graph
that
is
the line
constantly
graph.
expanding.
Yeah, like
We-
there's new.
We'll pin the version too, like the executor version.
Yeah, but that's the point is like if the thing that's running on the client is something we want to update regularly and is a rich ecosystem, and that's the argument for why
See,
we're running that on
okay,
the
I see what
client, then it by definition must be upgraded regularly. So where I actually feel like it would be easier for us to say well, I mean, like if you think about a CSV example, we can implement that very easily, right? Whatever is going on in that thing. And I get that the ecosystem of tools will be useful. I think there'll be chances where they're complicated and we can sort of fork or monkey patch the tool to route, internal IO stuff, file system stuff through a proxied layer through our Go stuff. And where they're not complicated and we want them to be used, we just rewrite them. But
Yeah, so
You know
as
what?
Dylan said, this is kinda this all routing via executor is kinda this stopgap measure, and we can say that if somebody really wants this very advanced tool like the Office proxy, let's host your own AI gateway, and then you can connect to your you will be able to unblock these tools and these workflows if you either allow the cloud AI gateway to make the connection to your endpoint or host your own. Two options for you depending on your security requirements. And we have only one dependency that we need to manage, like one service that we need to manage and handle the backwards compatibility instead of two. That makes sense to me.
I would say let's not worry about it. Let's figure this out later. Like I don't think like no one's asking for more tools at the moment. But when they do, we'll figure it out. But my process, I was just saying that I was thinking that the first thing Duo Workflows does is I'll just complete what I was saying. The first thing the Duo Workflow service does is it goes to the Duo Workflow executor and says, give me a list of your tools and the contracts, right? And so it then obtains the list of the tools and the contracts when it's starting the workflow. So think of it as a workflow handshake saying, oh, I'm connected to my executor. What are the capabilities of my executor? Right? And so the executor returns with capabilities saying these are the tools and these are the schemas for the tools that I support.
That's
Right?
kind of like the LSP.
Yeah, exactly. I mean, there's a reason, like lots of things follow the same pattern of give me your capabilities, return, like every package manager, like NPM, Conan, etc. They have this first call, which is give me a set of client, give me a set of capabilities that you select, that you support, server, give me the set of capabilities you support. And that's why these package managers are able to like cater to a long range of versions, is because they are doing this capability handshake. And then once you do the capability handshake, you then say, okay, now I want to execute. I now know exactly what tools are possible, right? I will accept or reject the workflow based on whether they're using this set of tools or a subset or long set or whatever, right? So that was my thought. Does that make sense? I didn't fully
it
explain
definitely
it,
makes
but
it definitely makes it more palatable to me. But yeah, I don't know. I still feel like you make relying on them having the same kind of Python API available, like just the list of tools is not enough, that the tool and the version, because whatever.
I meant the schema as well. So tool version and schema for the tool. So the schema
Right.
includes like this is the tool, these are the inputs, and this is the output.
Yeah, okay.
That's what exactly we send to the LLM as well. We send the schema, and that can be obtained easily with the line graph tools by just saying dot definition or something, and then you get the full schema back.
Yeah. Well, I think that can probably help. Um if we do that, does it change, like does it change our GitLab?
No,
Well,
it
okay.
doesn't change anything. It doesn't change the architecture.
Yeah.
It just changes. What we're talking about is a pretty minute point about the workflow executor, what language we're going to write it in, and how scalable we want it to be. And I wouldn't suggest we do this for day one either. I don't think for day one we want to say, hey, you've got all the tools possible in the world that you want. I think it's a pretty if we are going to be if the Duo workflow executor is a Docker container anyway, I think it doesn't matter which language we write it in. We could write it in I don't
Yeah,
know.
it's not just about it
Go
being a
and name
Docker
and
container. In the ideal situation, it's a wget command added to your existing Docker container. So
Exactly.
it's a wget command run at startup for your existing development container, which is why with Go that's just so much more achievable than Python. But that being said, I do get what you're saying, and it isn't as bad as I thought before. Like the problems wouldn't be as bad, assuming that, you know, the stable API of like input, output, list of tools, and like it is there. Like because those LLMs are pretty flexible and adaptable and understand what the tools mean to them. I think it does give you a bit more flexibility than I guess more static kind of programs. But I would still kind of rather see how far we can get with like a very trivial Go executor that people can
I
install into
agree.
their existing container. And then if we find ourselves limited, we can still try what you're talking about and build a second executor that's written in Python and actually
Yeah.
just see how much more opportunities we get as a consequence.
I agree. And because we're packaging it as a container, I think we have that flexibility. We can just change like version 2 of the container could be Python. Like it doesn't really matter.
Yeah.
One point though here, I think that this is a really great idea. But I would still implement this tool handshake even with the Go executor. That way, I believe it could be way easier for us to really swap the executors. Like if you would like to implement the version 2 Python with this breadth of tools, it could be quite like transparent from the workflow service, whether it's Go or Python. It's like, okay, now I don't have only 5 tools like read, write, file, run command, but I have all these tools. It doesn't matter to me.
And if you just do get capability, you're handling the issue with versions, right? Let's say we have a version of the executor that doesn't have a tool. When you're doing the handshake, you know that, right? When you're doing the handshake, you know exactly what version the executor is running and what tools it supports. And so let's say we build a new version of the executor with a new tool, for example, and now suddenly we have that access, right? We know.
I think that's a good idea. We can make the handshake and, you know, this particular protocol match what the schema looks like ordinarily for LangGraph. And then that also gives us kind of forward compatibility opportunities in the future.
Mhm.
Okay. What else? Well, I actually have to wrap up now, but I think we've made progress. I think next week we're actually at the point where people can start like making projects for these different things, or like trying to stick this inside the AI gateway, see what happens. Someone can actually write a Go executable that understands this protocol. Someone can start writing the checkpointing APIs in GitLab, and someone can start writing this LSP trigger executor process.
Yeah. Exactly. So I think what we should do is we'll make a list of these components that we need to write. That's exactly what I was trying to do initially, is trying to make a list of these components that we need to write and then just assign owners to them. Like some of them are simple. I think the Duo workflow service inside the AI gateway is probably the most complicated part where we need more hands. And of course, it's the UI bits, right? The UI bits can't be forgotten.
So I'm going to put all 3 of these in a comment because I'm going to wrap up for the day. But if you guys want to follow up this today, you can. If not, it'll be in the blueprint on Monday, and then we can start working on things.
Sounds good.
All righty. Thanks, guys. That was very productive.
Yeah, absolutely.
Have a good one. See you later.
Have a nice
you.
weekend.
Bye.
Bye-bye.